Alright, we should now be live. Hello everyone, and welcome to today's live stream where we're doing a little change of pace. I will be following someone else's tutorial. Sean Terrelle, apologies if I pronounced that incorrectly, made a very nice effect which is basically Raymarching fractals in geometry nodes, using geometry nodes as the rendering engine. So I was like, that is very, very cool. The results are very cool, and I'm thinking of ways to apply this to other signed distance fields, which could be very, very interesting. So I will be following along with the tutorial. I've put the link in the live stream chat so that you can follow along. And yes, let's get started. So first of all, I think I need to change the camera resolution just so that it will kind of match the rays that I will be firing out of this. So yeah, I won't be paying attention too much to the chat because I'll be bouncing between the tutorial and this. I'll have the closed captions on that so that I won't have the audio playing for the time being. So let's get started. I'm very excited about this because I've never attempted something of this manner before. So I'll bring the camera into here, and actually, is there an active camera? We don't have that just yet. I was hoping that the active camera node input came in 4.1, but apparently not. So first of all, we need to go and make our grid. So grid, and the way that Sean has this set up is with a value node put into here. Let me turn on grid snapping. I would recommend watching the tutorial if you just want to get the end result because, well, it's much better than what I can do. This will be rather slow. And I'll be experimenting with it along the way. So there's that part, the grid's there, and then we need to transform it to our camera's orientation. So let's set that to relative and then apply this to here and here, which means that now we have the plane right there. I need to make sure that that is correct. I need to see what happens after the fact. Okay. I think we need to set it forward by a little bit, so we can just move that before the offset. Ooh, by 1.4 meters apparently. Man, that fits quite well. Maybe just a tad less, but it should be fine for now. So here are the transformations. Size we want to be 1, which we can resize that dynamically. Then this, I'll set it to 1024, even though that will be absolutely terrible for performance, so I will divide it by 4 so that we can work with a quarter resolution. Oh, that's actually really funny. Okay. So now that we have that, let's go and let's see the next part. The next thing that we have to do is store a named attribute for the ray distance. So ray distance. There we go. Oh, and is that a vector or a float? Oh no, that's ray direction. It's a little hard to see the direction. There we go. It's a little hard to see the text on the video because I do not have it full screened at this current time. So now for the ray direction, I think we just need this to be rotate vector. Ah, dang it, not that one. Ever since the new rotate vector came along, finding the old one has been a pain in the buttocks, as you can see currently. Vector. Okay, which one is it? Oh, it was... Wait. Okay, no, I am just searching for it normally. Utilities, rotation. Let's see. Rotate vector. Wait, where's the old one? Vector rotate. Okay, there it is. Dang. Let's set this to Euler. Then I can have this here and then just a vector so that we convert that to there. I actually need to check if that's what they do in the tutorial. Oh no, they just use a subtract from the camera position, which is way easier to do and much more logical. So let's just go and do that real quick, then normalize it. Should have done that in the first place, but I digress. Normalize just to make it so that it has a power of 1. There we go. So we have that there. Again, the link to the video that I'm referring to is in the chat if you want to follow along. Let's see, let's move it forward a little bit. Oh, looks like we're already getting to the fun part, which is the simulation zone. So instead of doing all the steps at once, Sean made it so that it would happen with the simulation zone, which makes it easier on our computers because we're not using the GPU, which is very, very sad. Geometry nodes cannot use the GPU at this current time, and probably not for a long, long time. But since it's all done on the CPU, it's very slow, so doing this every single frame for the steps instead of all at once is a lot faster. So it looks like we're going to reference the direction attribute, the ray direction, and then scale it by 1 from what I can see. And then we get the position. Whoops. Okay, looks like we may be making the fractal that will be rendered soon, but I'm not sure. We need the distance, and then a subtract by 1.5. Yeah, subtract. I'm actually finding out that this workflow is actually pretty similar to my regular tutorial or live streams. Because I'm just saying stuff and then I make it show up. That's pretty funny. So the distance, why is it subtracted by 1.5? Oh, okay. Yes, I see. I currently see. So we want, okay, a set position. This is a test to make sure that it is working. So if we do that, whoa. Okay, where'd I screw up? Ah, that's where I screwed up. There we go, just flip that around. Okay, we're getting there. And then the ray direction. Okay, where did I mess things up severely? Oh no, that's a subtract by 0.5. There we go, okay. So now it is working, kind of. So right now, the rays are tracing just a sphere. So I guess this could be any object that we want. And also I want to set the shading to smooth before any of the complex stuff happens. So now we're just tracing a sphere. So from here, it looks okay, and then as the ray accuracy becomes more and more, we can see that the sphere just appears, and it seems to be all right. And now, let me turn on these just because it's easier for me to see what's going on. So now it's just assigned distance field, which means that I can't, wait, let's reset this. Okay, let me turn off the cache so that we can see the updates way, way faster. So now it's working. So now, in theory, this could be any assigned distance field that I want, potentially. We will see. Let's Control J that so that it's better. Okay, replay it. So now, from another test that I've done, if we use a separate XYZ and then use a smooth maximum, or no, smooth minimum, we should be able to get the blending, like a blended plane and sphere. It works. Okay. Yep. We can see that it is now blended from the camera's perspective. So yeah, we can put any distance field that we want, and then boom, it works. Oh, we can do so much with this. Oh, this is going to be really, really good. Because this could be... This is brilliant! Okay. So I could put... For the sign distance field, it doesn't have to be something that we generate. It could be something that we reference. Say, if we get the proximity. So, again, this might be horrendously slow, but oh well. There we go. Oh, let's set this to relative. Now, this will blend between a sphere and the monkey, which I wanted this to be the exact opposite. So now, as we can see here, Ooh, dang. It looks like there are... Oh, yeah, that's why. If it gets too close, errors will start forming. So we need to just subtract like 0.001, I assume. There we go. There we go, okay. So now we can see that that's working, and if I turn up the blending to like 0.4, we can now see that, boom! It's now doing the accurate blending, which is really, really, really cool. This is amazing. So another thing that Sean pointed out, again, I hope I'm pronouncing their name correctly, or that would be very, very embarrassing on my part. But yeah. There we go. Let's do that and that. Let's make sure that everything in the chat is okay. There we go. But yes, there can be so much power with this. Let's use a set material node so that we can make this look a little cooler. Now, again, what Sean did was make this a metallic kind of thing. So as we can see with that, we now have it blending. Oh, that's so cool! That's so much better than using volumes like what I was doing before. Now, it does mean that there are, you know, errors like that, but that's fine. It's just anti-aliasing, you know? Minor errors here and there. Oh, this is cool. So yeah, we can do like the, what is it, the, not T1, is it the T1000? The Terminator that blends into the floor. Let's also have it so that we can have the repeat zone do this, so that we don't have to wait. Am I in 3. No, I am in 4.1. Okay, repeat zone. There we go. And this should probably work in 4.0, but we'll see. So if we just swap that out, and then do this, we can set how many rays we want. But as we can see, it's a little bit laggy. Just a tad. There we go. So, oh, yep, that is rather laggy. Because we're not using the GPU. Shame, really. But yes, we can see that when that happens, it is blending. Actually, yeah, let's just view it from here. Little... Okay, yeah. Could I don't know. If I wanted to make this more efficient, would I need to make it check the distance to the mesh every single time? Because I assume that's what's making this worse. So again, there we go. Oh, and another downside is that this will be reading the actual distance function rather than... yeah. Okay. Interesting. Interesting. Okay. Another thing that I'm going to do is make it so that our kind of part here, let's use a multiply. So that if it's like that, let's see if this works. This should make like a pseudo sphere. Oh, nope, it's not doing that. Oh, wow. Well, that's an interesting side effect. Huh. Anyway, let's go and switch back to the repeat zone. The simulation zone, so that we can get fast performance with the rendering, so that we can see it resolve in real time. Oh, that's so cool. Okay. So, other things that we can do with this. We can use the... How do we stack the ray hits? Or wait a minute. Let's store a named attribute, which will be our signed distance field. So SDF that we are using for rendering, and then view this in the thing. So SDF signed distance field. Let's go and reference this and replay the simulation. There we go. So here, I guess we can see the inaccuracies between the steps in that. Oh, that's so cool. I guess the big upgrade that we get with this versus doing it in the shader node the shader editor is that we can use any mesh that we want with that. Interesting. Okay. And we could just make it so that... Actually, how do we count the rays? So I'm just going to... This isn't going to be accurate, but I'm just going to add for every single one of these. But maybe I could do a check so that if it gets close enough, it won't add to there. So if the distance is greater than 0.01, then it'll add to the age. Or less than, so that we can see the... There should be a way to figure out the ray accuracy, but I am forgetting at this time. Let me play through the tutorial one more time. Oh, another thing that I saw just from looking at this. Okay, let's clean this up a little bit more. So I'm going to plug the SDF into the named attribute so that we can view it in the shader editor, but also just plug this into here and not worry about it. And we just need this subtract by 0.001 here so that, you know, errors do not occur. So we can make this even simpler. Very nice. Okay. Raymarch. There we go. So this is ray direction. Then this is grid. Oh, grid transform. There we go. Okay, that's pretty cool. We have it working. I'm happy that works well with a mesh. Interesting. Oh, I have an idea, but it's a really, really, really bad... No, yeah, that's a very bad idea. I was thinking of instancing spheres for every single iteration so that we can see the scale. But at these resolutions, it'll get really, really bad really, really fast. Oh, but it could be cool to do that. So let me lower the resolution by another quarter so that we can just see this. How many points is that? Okay, wow, that is a very pixelated renderer right there. But using the simulation zone, we could, yeah, let's use another simulation zone, and we're going to instance on points. And I'll have this be an icosphere. Yeah, that should be decent. And then the SDF will determine the distance to there. And then we'll just join that into the fold every single frame, and it will lag out considerably. But it'll be cool for the frames that my computer survives. As we can see here, we already have this many. Oh, wait a minute. Yeah, so here we should be... Ooh. Yes, this was quite the mistake. But maybe if I lower the resolution to, like, 16... will be better. So let's boot this up. So we should see that at the monkey. Oh no, yeah, we just can't see anything. Maybe it needs to be 0.5. Oh, if nothing else, it has a really cool look to it. Here, let's make this even smaller. There we go. We can see that the closer it gets to the actual surface, the smaller these spheres become. But yeah, with it being like that, it's not really the best. What? If I made them transparent, that would lag out my computer considerably. But it might be cool. I don't know, let's just go with the usual, the fast version, where you just render it out and then it's like, oh, it just works. 128. Do I want this to be more? No, that should be fine. Okay. Oh, and then next is the fractal setup. So let's make the actual fractal, or let me try out the sphere, the infinite sphere SDF that was shown. So just one sphere, you know, that's cool, but what if we had infinite spheres? For that, we can just use a wrap node, which will basically loop it around like the old games. Then here we can see infinite spheres. Let me up the resolution once again. Actually, yeah, 512. Oh, and it's still running in semi-real time. That's cool. So here we can see with the renderer, we are getting the infinite spheres. And then I could just get the distance from the camera, but... Yeah, actually, I could just get that from the input geometry, or no, texture coordinate. Camera, we just get the length so that we don't even need to store it. We can just use the GPU for its intended purpose. So here, if I use, say, map range, so that we can view this a little bit better. There we go. Essentially a Raymarched world, which is really, really cool. I really like Raymarching. I just wish that Blender had a way of integrating it better, because at the moment it only really supports mesh editing and all that. So yeah, there's that, which is really cool. But the plus side with this method is that we can get actual rendering happening. So here we can see that all the spheres actually exist in the space. Yeah, oh, and I could make it so that if the error amount, as we can see here, if there's a high enough error rate, then it'll just turn it invisible. So I could do that. If the error rate of the SDF, because it gets the distance to there, if the distance is greater than, like, 0.5 should be fine. I'll just plug it into the alpha and let's see what happens. Did that do the exact... Yes, it did the exact opposite of what I wanted. So here, as we can see, there we go. That's better. Oh, that's... And as it keeps going, we can see it rendering further and more accurately. So that's the power of this method. That's so cool. Let's see. And again, if you want to make this as well, the nodes, the link to the tutorial is the first message I sent in the chat, which actually, I'm going to just Control-C, Control-V that. It's by Sean Terrell. So go check it out if you want to try this out for yourself. It's weird that since this is being used for a renderer, we can use the for now, like all the regular passes, which is very, very odd. So if I want to plug this into here, we can see that it is working. It's so weird, but so cool. I guess if I want to store other data on this, it's not available. Oh, there's a good chance that I didn't copy the link accurately. Here, let me... Oh, dang, there's ads at the moment. Oh, that's new. Here, I'll just post the link in there. I'll delete that other message and then post the actual link. There we go. There you go. Okay, wow, we have 61 people here. Hello, everyone, and welcome to this Raymarching extravaganza, which is... I really like this. So, just so that you all know, this is not my design for the nodes. This is Sean Terrell's. The link to their tutorial is in the chat, as you can probably see. But with this, we get the ability to Raymarch, and it puts it in 3D space, which is really cool, because it leads to these crazy effects, which is amazing. But this also works with, say, actual meshes. So here, we can see that I have the classic Blender monkey, and whoops, there we go. My camera is having a whale of a time at the moment. Here, let's just go over here, there we go. But as we can see, since we're blending between different distance functions, it's blending between the monkey and the floor, which leads to, there we go. It's a really cool blending technique. Now, it is a little slow because we're using this on the CPU instead of the GPU. It's kind of our only way with simulation nodes. It's just not supported to make this work with the GPU. But if anyone wants to get in contact with me, if they know of a way to change that, let me know. That would be really, really cool. Just to see this working so fast. That would be amazing. But yeah. So with this kind of rendering technique, we can make all of that happen. So one thing that I'm not sure about anymore is if here, with the grid, if I need this to be closer or further away from the camera. Because right now we can see that it's not exactly 1-to-1. I'm just assuming that, okay, yeah, it needs to be like 1.3 something. 1.38, yeah, there we go. Now I'll cover up the entire camera. Nice. Let's play it again. There we go, we have that working. So now I want to change it to another kind of signed distance field. So we already have the infinite spheres doing its job, just a wrap node repeating that. But let's add in a little bit of noise into the fold, because that could look really, really cool. Because right now we just have spheres, but what if we want to add noise to these spheres? So to do that, let's have the position, have this be noise, and then add some of the noise into there. Let's denormalize it, which you could just subtract by 0.5 in order to make that work. But with this, we should see that we have a very different look happening. Oh, this is so good. So here we just have that happening. And we can see that there are some errors occurring, which I need to look into. Maybe that's because it's going heavily into the negative. I will check that out. I'm assuming that, like, the error rate is just not good enough, like the solve for that. So here we can see that I can warp this with noise. Let me change this down some more, maybe up the detail. Maybe up it even... Oh, wait, I can't up the... Oh, no, I can. So let's set this to be 0.5. So now if you ever wanted a meteor generator, that is a little weird. Oh, that's... Seeing the projection like that is very cool as well. Like, look at that. Oh, that's amazing. Oh, wait, I guess that means we could potentially also make an infinite amount of monkeys if I play my cards right. Yeah, I could do that. Okay. So if I do this, I could get an infinite amount of the monkeys. There we go. So here we have an infinite amount of monkeys for the price of 1. Oh, that's cool. So this is just the wrapped distance. I can change this to length and it'll do the same thing. But we don't want to worry about that at the moment. So we can have that and just have an infinite amount of those. Relatively. And now if I do this... Like, I'm still not sure why the glitching is happening when I do that. I'm just going to assume that it's like, there's not enough detail in the renderer, in the amount there. But also, as we can see here, I can warp the monkey with that, which is, again, very, very cool. The thing is, since this is a signed distance field, each monkey will have a different noise pattern. Right? Yeah. Each one will have a different noise pattern when it renders. So even though there are an infinite amount of monkeys on the screen, they will all have different noise patterns because it's treating them all the same. Like, look at that! Oh, that's so cool. Oh, I know what's going on with, the cuts are happening there because the geometry proximity node is not taking into account... the monkey does not have an interior volume. So as soon as it gets close to the middle here, it just completely blanks out. And then when it goes into the negative, it just cuts a hole straight through it. So essentially this is a Boolean, which, speaking of Booleans, I could make a Boolean. So if I get a length node from here, just a sphere, actually I'll set this back to a distance. If I use a subtract node from here and then, or maybe a multiply by 0. If we use a greater than node, it'll preserve the distance, but if not, it'll set it to 0. So here we can see that maybe I think that might be doing the exact opposite of what I want. It should be cutting out of the monkey rather than this current thing. Oh dang. Greater than? No, maybe we want a subtract. Nope. Less than. Oh, not a logarithm. Where's the less than? Come on, you can do it. So yeah, if you all have any ideas, okay. So it looks like it's like half working. Even though I think that those errors are occurring due to a bigger error. So let's multiply this by a lot less, or by a lot more, so that the hole just gets punched out completely. Okay, yeah, we can see the errors that are occurring. So let's just not do that. Use min slash. Oh, okay, so it is a minimum. Okay. I'm so used to. Yeah, there we go. Thank you. I forgot about that. So that, and it'll just cut it out. But we should see... Oh, okay. So if I do this, it'll only cut it out for the first one, but the other ones will be okay. But if I use the wrapped position, then it won't. So we have that. Is there anything else you all want to see with this kind of effect? I think I'm going to... Okay, so for the distance, I'm going to use one sphere... and then cut out of it with the sphere that I currently have. So let's set this to 0.5. Then use a subtract here to get the distance from there. So a little bit of trivia right here is that... Let's set this to be negative so that we can see. There we go. Here we can see that that sphere is cutting out of that sphere. Let's set this to be smaller. So with Unreal Engine and their Lumen rendering system... Actually, why is that... Why am I not seeing the interior right there? Why is it just cutting out completely? I'm a little confused about that. Huh. Oh, maybe it's just because there's a greater than? Yeah, okay. I need the actual distance, not just a greater, less than or a greater than. If it's a harsh cutoff... Oh, wait a... Oh, that's funny. I made an oval with that shape. Maybe I need to multiply this by... Oh, no. Minimum. There we go. Well, that just joined them together. But maximum makes it so that they intersect. But I want it so that they... The other one cuts out of that. Okay, so that's doing something along those lines. Maybe it's just not far forward enough? So we have that. Let's do a minimum once more. Nope, maximum. So we can see that there's... Oh, with the distance inverted. That makes sense. Thank you once again, El Benko. Sorry if I mispronounced your name. Let's multiply this by that, set it to -1. Now let's try it again. So, wait, -0.5, and we should see that sphere is now... Yes, it's now cutting out from there. Thank you again. Let's see. 3D Mandelbrot set. I haven't tried out the fractal just yet, and we can see that the sphere is cutting out of every single one. Let me turn this off so that we can just see this rather normally. There we go. Oh, another thing. Okay. I know I'm getting very sidetracked. But that's the fun of this. We have so much more power now. Okay. We don't need that. We can keep the noise, because I can still apply noise in post. So here, if I just add that to there, we should get noise. So every single one of those will be different. Now, it kind of looks like a meatball or something along those lines. Let me just make this simpler once more. That is the monkey and the floor SDF. Let's just move that out of the way. So we have all of that repeating. Let's undo that. Let's play it. Uh-oh. Did I delete something important? No. Okay, I know what happened. Okay, bear with me for 1 second, folks. When you Control Z, there's a good chance in the current version of 4.1 that Blender will just stop working, or the simulation will just stop working, which is very unfortunate. So I'm just going to boot it up once again. But yes, I will be trying out the fractals next. Or maybe a little... Uh-oh. I broke something. Oh, it was the inverted thing. Okay, so I did not break it. Okay. I did not break it. Okay, we're good. It's lagging a bit, but that's okay. We have our maximum here. So we have that there, and a hole's being cut out of each and every one. But if I use the distance here, we can see that it will only cut out of the first one and not the other ones, which is good. But yes, if anyone wants to get in contact with me about making simulation nodes, like an add-on to make simulation nodes GPU compatible, I would be all for that. Because at the moment, the only real GPU accelerated thing that we have in Blender in terms of like modifiers is the open subdivision surface modifier. It's so cool seeing it just resolved. You can see the rays going out. That's so cool! But we can see the inaccuracies increasing because there's not enough grid resolution. Though I wonder, would there be a way for me to dynamically add in resolution where I need it and then take it away from where I don't need it? That would be interesting. I don't think Python has that capability. Well, in here where geometry nodes uses C++ or C#, I forget. It uses one of the C programs. For speed, I believe they said, when they were talking about the conversion. But yeah, the upside is that if we could get simulation nodes to be compatible with the GPU, we can get smoke simulations working at a real-time rate, water simulations, basically any simulation in real time. EmberGen is a GPU simulated smoke simulation program, and in there they can export all the data that you want, which is really cool. It would be nice to get just a little bit of that power in Blender without having to wait 15 years for 1 billion voxels to calculate in sequence, because it's on the CPU. I'm not sure if simulation nodes is multi-threaded, but I assume no. Okay, what was I going to do next? Right, in the shader editor, since we have the position input geometry, since we have the position here, we can go and use the wrap node to look at the position. There we go. So this is the position that geometry nodes is seeing, which is really cool. So if we do this, we can see colors, psychedelic, and all that cool stuff. But yes, what I was going to do is snap this by 2 and then white noise so that we could see. Looks like I'll need to snap it by 4 and then subtract it by 2 beforehand. I'm aiming to get 1 color per cell. There we go. So now we have 1 color per repeat cell with the wrap zone. So here we can see 1 color for every single one. Now it is a bit hacky because I'm not actually storing the color in the render. I'm going into the shader editor and doing that, which is doing the same math, but, you know, really, really hacky. But that's cool. I like that. And this could be, again, if I do this, I can make it so that it has any amount of colors. Because, fortunately, we can get the position on the GPU, which is, again, in the shader editor. Alright, what else? What else? Right, I need to actually do the fractal. So for the fractal, Sean uses the repeat zone. And then it looks like the position is put in, oh, whoops. Okay, I need to do this position. The geometry input does not seem to be used, which... I forgot that that was an option. Wait, does that mean that can apply with the simulation zone as well? You can just get rid of the geometry input. I don't think so. Oh, you can! Well, man, I forgot that was an option. Okay, so it looks like there is a wrapped node. The quality, I should take a screenshot of that because the quality of the YouTube video is a little compressed with me currently streaming as well. So we need a dot product. I think it was mentioned that this kind of squares the vector, or I'm forgetting. But we have that. I'm just going to skip forward by a bit. Then we divide by 1.333. I remember that from another fractal that I worked on a long time ago. 1.33. What's the square? What? I'm assuming it's like a square root or something along those lines. And then we scale the wrap vector by that amount. Again, I'm following Sean's tutorial on this. But if we do this, and then plug this into the output, and then we need a math multiply node, and then we have this set by 1. Okay, let's just check the setup again. Then we want to separate we want to absolute and then separate the z of this position. So absolute, ABS, absolute. And then multiply it by 0.25. I'll figure out what all this does, but first I want to get it set up. And then we divide by what I'm assuming is the like repeat counter here. So if we do all this, and then we don't forget to set the iteration counts. Okay, I don't know about that, but let's just try this and see if it works. Oh, wait. I was like, oh, is it working? But I was looking at the actual, the tweet. That's funny. Okay. What am I doing wrong? So I'm assuming, oh, the yeah. Iteration count. That iteration counts. Still, oh, that needs to be a value of 1. There we go. Oh, there we go! The fractal's now working! I did not know it was that easy in order to make that kind of fractal. That's really, really cool. But yes, now we have that working as intended. There are so many possibilities with this. Again, special thanks to Sean Traley for making that tutorial. It is amazing. So in theory, this would also work with the shader editor, but you would have to do some different things in order to make it repeat properly. So this is, let me put this into a frame. This is fractal. Oh, fractal. Okay. And then that gets multiplied. And that happens by that, and then that and that. I'll figure out what all this does soon enough. What's that? Like, look at... that's so good. That is so good. Okay. Let's change the shader. Again, I can change the color for all of this. Oh, dang. Yeah, sorry for the LSD here. Ludicrously, I do not have a good acronym for that. But yes, this was the example that Sean used, just showing that it's becoming real and all that, which is very, very cool. Though I do want to find out, how do I count the amount of iterations until it gets close enough to the center? Because doing that, I can get an ambient, I believe an ambient occlusion style thing. I think I tried that here. Let's, oh dang. It looks like this is getting, this is floor blend. I'm not going to worry about that. We can delete that. That's just a sphere Boolean. So this is spheres, infinite spheres with Boolean. There we go. I think I can do this either way and it should be fine, right? Yeah. So, who knew a fractal could be so simple in GeoNodes? Wow. So that separates the Z. Actually, I'll label this separate Z. Okay. Wow. And then there's the wrap node, which I'm assuming just makes it so that it repeats instead of... Oh, interesting. Yeah, let's play around with this by a bit. So, fun fact, in Guardians of the Galaxy Volume 2, I believe they used a fractal very much like this for the interior of one of the planets, which is very cool. Let me set this to 0.25 once again. Yeah, there we go. That's a better result. And from here, it just looks so good. And again, I'm going to go into the shader editor. Let me get the geometry position and then separate the Z. All of this is becoming a mess, but it's so cool. Again, here's the distance from the camera. Very cool. Distance from the... Oh, that is cool. And it looks like we're getting some blur and fog in the background. Like, look at that. That's amazing. And we can see the pixels on the rent. Ah, that's hilarious. What if I made it retriangulate every single frame? Would that be a good idea? Then I like how we can just see the kind of depth map like that. There we go. I wonder... Oh wait, since I have the sign distance field, I can put my recursive subdivision effect on this and it would work. Oh, so many possibilities. Let's use a map range and then plug this into the color. There we go. We can still keep that as the alpha. And this... Yeah, there we go. It's interesting how it warps the further away it is. And it'll never be 100% accurate here. Yeah, what else? I think that color is a little too bright, so let's go and do it again. It's clamped, correct? Let's just put in a color ramp. Should be fine. There we go. So it is funny how it's orange until it... Yeah, even when it... Intriguing. Is that because I'm assigning the... Oh, no, yeah, no. I'm just being a little bit dumb at the moment. Which I know is extremely rare for me. Okay, what else? Let's play around with the fractal more. Let's set this to 1. What happens then? Okay, we get a different result. Interesting. Set this to be like 1.5. I need to remember 1.33 for the other part. Oh, I like that one. We can see the spheres a bit better. And also, I should mention that this works with lights, except not entirely accurately because, again, the geometry is actually there. So it's you know. Though, if I store the position of it, I may be able to clip the alpha there. But yeah. Let's set this to be a certain value. Maybe let's turn up the roughness by a bit. Like that. We can add in soft shadows. So this is a very complicated way of just getting Raymarched stuff working in EV/cycles. But it's not a bad way. Like, I guess this means that I could just apply the modifier and then just chop out this, and then boom, I have a mesh of a fractal. Easy. Like that, I can make the sunlight work so that when that happens, it's just so good. Okay. Let me turn up the ambient color, so yeah, we can get the sunlight working, and it all just looks fascinating. And then, oh, I have a really, really, really bad idea, but it might just work. What if I were to blend the fractal into the monkey head? That's a really bad idea, but it could be funny. Let's plug that into there and then run it. Dang. And what if I were to just subtract from that so that we can get an interesting look with all that? Uh-oh. What happened? Ah, okay, no, that was a bad idea, apparently. -5. There we go. Negative, or... Oh, we need to add. That's why. Okay, so let's add 1. Okay, nope, it's just showing... Why does that look like Homer Simpson? No, I need that to be +0.5. Nope. Okay, let's set this to be add by 0.1. Because I want to make it meld into it. Wow, that is an abomination. But we can see that's sort of working. Wow. Now that is really interesting back there, seeing the renderer freak out. But I think this is a bad idea, so I'm just gonna go and whoop, just chop it out of there, just act like that never happened. And now let's plug in the SDF to there and see what happens. Okay, since I subtracted, it's doing that weird melding thing. Again, very intriguing. But now I'm thinking of many other ways to make this kind of effect work. So I also could make this, work. I can increase the amount of layers to the fractal more and more and more, but I don't think we need that many. Like right here, if we set this to 2, we can see the fractal in that state. Let's set it to 4. We can see some more of the spheres being formed. And actually, wow. That's cool. That's very cool. Let's keep turning it up. Wow, that turns really, really detailed. A lot faster than I assumed it would. But what if instead of... this... Actually, yeah, okay. What happens if I use the X into there? Oh, okay, so it's similar. Yeah, okay. It looks like the Z gives it the floor. Interesting. Now, another thing is that... Oh, this is probably an extremely bad idea, but I'm going to try it anyway. What if we use an icosphere for our renderer? But... let's see. It's going to work. This is a horrible, horrible idea that I do not recommend anyone do. But here, we're Raymarching from the camera in every direction. So now, we're just getting the actual environment as like a 360-degree image. Let's set this to 8. Oh, now we're getting the lag. But as we can see here, from the camera's point of view... Oh, and we can see the interior! Oh, that's cool! Okay. Do I want to push this even further? That's a cool... Oh, that's very interesting. I need to cut through this and see the different patterns, because I can extract textures from this. Let's set this to 9. And let's run it again. Oh, it's gonna hate me. Yep, Blender hates me at the moment. But we can see it is positively, or maybe not positively, but it is working. We're getting the Raymarching in every direction. So we're basically getting the environment. So in theory, I could just convert this into a mesh very easily. And then here, oh, it's that, whoa, okay, I've seen this pattern before. I've made this pattern. We zoom out, we can see like the rings happening. So that's just this whole thing is just that in 3D. That makes sense. And that is very fascinating. Oh, I understand now. So that also means, again, if we just take the camera and rotate it, everywhere we look, it'll be an accurate thing. It's lagging because since the simulation was dependent on that, it's saying, oh no, we need to update. Wow. Okay. It's also funny that the camera would be clipping into this if it weren't for like the first yeah, if I set this to 0.1, we should see it really hates me. But from here we can see that it's starting, that's like our clipping distance. But we can see it is making something. Oh, we're inside the fractal at this time. So we get to see all the cool, yeah, there we go. We can see all the details in that fractal, and it's incredible. Okay. What else? What other data can I store? Like, I should store other data. Okay. First of all, let's go and put the grid projection in there again. Let's play it once more. We're almost at an hour now, but I'm having too much fun with this. We can store other pieces of data in the zone. So here I'll just label this A for a, attribute. So that when we resimulate, I can go and see what that data looks like in the shader editor. What is it? Let's use a greater than. Okay, this is basically the detail counter. Which means that if I snap and then white noise. White noise. No, I need a white noise. Ah, that worked much worse than I thought it would. I was hoping to get random color per, like, detail level. But it doesn't seem like that is able to happen. At least in its current form. Maybe I can store some more data in our fractal loop here. So what if I just add 1 for every iteration? I'm not sure if this is going to work, but it's worth trying. So let's just plug that into our other attribute. This will just make it so that it goes up by 1 every single frame, yada yada. Greater than? No, okay. Yeah, it's not reliant on any of the internal data in the loop, so yeah, that makes sense. It just adds 6 to it. If I add the dot product every single time, what happens then? Okay, now it looks like we may be getting the detail level. Potentially. Let's take a look. Oh wow, my stream viewer is extremely delayed. I'm assuming that's because of how much lag I'm putting my computer through. Because again, I'm rendering at 512 by 512. Ah, there we go. So here, by storing that every single time, we can see the kind of detail levels. Oh no, it's the distance from the spheres. So the cutouts and the actual spheres that are there have that. So I'm not counting that. Maybe I could just plug that in there? Let's take a look at that. Oh no, that's just blindingly bright. Huh. Divide by 1.5. Let's take a look at that one. Looks like we get a better result with that. Well, I'm not gonna worry about that all too much. Here, let me go and switch this to be a vector. Let's get rid of that attribute right there. Do this. And then let's plug in the position so that we can view every aspect of it. Now, in theory, oh my goodness. That was a little unexpected, but this I'm assuming is like the UV map of the entire effect. So let's separate this one at a time so that we can see what's going on. If we get the length of all of this, or no, the Z direction, we can see... Oh, wait, is that the inaccuracies now? Yeah, okay. That's basically... Okay, interesting. So that'll glitch out severely. Let me get the length. Ah, okay, that's cool. Wait, that looks like a subdivided, grid. Interesting, interesting. Oh, that's cool. That's very cool. Let me plug this into there, or no, into that color ramp. Take a look at the output. Let's delete the unnecessary nodes just because. And I can divide this by a large amount in order to make that gradient a little bit better for all of us. Or no, I need to set that to like the power of 0.5 to make it better, or power of 2, 0.1. I'm just trying to make that gradient a lot softer, because apparently... Interesting. I'm just going to go and reset this again. Fascinating. Okay, let's just go and switch that to there. Again, very, very cool. What other data was I going to attempt to get out of this? I'm not sure. Just for fun, I'm going to try adding a wave, a sine wave to this. Actually, let's just get the length from the center. So let's get the position, get the length, which is basically the distance from the center of the object position, use a sine wave, and then just plug it into there. Something horrible is going to happen this time around. Oh, no, because I forgot to actually connect it. Okay. Odd. Let's set this to like 10 and then decrease the effectiveness it has on changing that entire part. 0.1. Okay. There we go. Now we can see that sine wave is now affecting all of this, leading to a very fascinating result. Let's go and click on that. Again, here, do I still have the link copied? Yes, I do. If you want to see how the fractal and the Raymarching effect was made, Sean Torelli made a tutorial, which I just linked in the chat. Be sure to go and check it out and give them a like, subscribe, all that good stuff, because this is very valuable information. Okay, let me turn down the effectiveness of that, so like 0.01. Just so that we get the hint of the sine wave happening. That's a little less than a hint, but we can see that it is functioning. Oh, is it causing cutouts? Oh yeah, I think it's causing straight up cutouts. Let me just do that by a little bit less. Okay, it's almost causing cutouts. Do I need... Yeah, I need a minimum. Or no, I don't want a cutout. I want a multiply. And that... Wait. Clamp. Let's clamp that. Okay, we don't want that one either. -1. Minimum? Maximum? Okay, and it's not Booleaning. Interesting. That is... Wow. Wow. That is something else entirely. Set this to 5 and see what that does. Okay. Looks like it's trying to Boolean, but the inaccuracies lead to garbled pixels everywhere. Okay. Maybe I'll just offset the Z position of the fractal using the sine wave. I think that would be better than completely obliterating it all the time. So vector math, we're just going to warp the space that the fractal is in. So there we go. Let's just bring our sine wave over to there. but I'm going to use a vector math multiply to make it so that it will only affect it on the z-axis and by 0.2. Let's play it. So now we should see that the sine wave, I clamped the sine wave. Let's bring that down by a bit more. We should now see that we are now warping the fractal using the sine wave. Cool, very cool, very cool. Look at that. That's amazing. I could offset it using a noise texture as well, so let's try that. Let's use the position, and then offset that by the noise texture, so let's set this to a scale. Turn off normalize, or subtract by 0.5, whichever you choose. So now we should see, yes, it is now cheese. Let's set this to be a lot lower, set the noise to be less detail. Run it again. There we go, okay. We can see that it's now being warped by the noise texture. Let's bump that up by a bit. Get some really weird warping happening. Wow. That's actually a bit freaky in my opinion. I don't think many people would disagree. But yes. Yep. I am tempted to try to make this work in the shader editor, because now I feel like I have a grasp of what's going on. But I'm not sure if I fully know. I'll do that off stream. Okay, anything else I should try? I could try true shade tiling. Could be interesting. Maybe not. What other shapes could I do with this? Okay, or maybe I should end stream about now, because we already have the effect working. Let me check through the stream to see anything else that's happening. Okay, yep. That seems to be it. Okay. And I could just make this points. So, oh, that's what I should have done. Here, I'll have this be 2 points, mesh to points. So this will make it eat faster. So here we can see the points going to where they should be, so that we can visualize all that great data going around. But we can also set the point radius to be the assigned distance field, the distance to the surface. So here we can see if it's close enough, it turns to pretty much 0. So that's basically the inaccuracy tracker, which is pretty cool. Let me set a minimum radius. Oh, this is lagging out severely. So there we go. If they're overlapping, Blender has a really hard time with all that. It'll keep getting less and less, but it'll never be 0. Due to the way I set this up. Actually, no, let's set this to be a maximum 0.001. So that there will be a minimum, yeah, there we go. Ooh, dang. They'll get bigger the further away they are. But also, they will be like that, which means if I render in cycles, GPU compute, these will be perfect spheres. We don't have point clouds working yet in Eevee. Hopefully in the next version of Eevee, if it comes out. But yeah. Let's do 0.5. That's an interest. Uh-oh. Oh, Blender really does not like that. Tons of overlapping points. Or actually, no, it's doing it. It's dealing with it okay. Let's switch this back to Eevee. Oh no, wait, that's Eevee next. Let's go back to the old version of Eevee because it's oddly enough better at this point. Anything else? What GPU do you have? I have a 3060, which is basically useless with this because this is all being calculated on the CPU. If this was calculated on the GPU, it would be lightning fast. I would be able to render this at any point in real time, but Blender and the GPU do not go well together, unless you're in the shader editor. What's in the sim zone? Just the thing that moves the mesh closer to the signed distance field, as we can see here. There we go. Union equals minimum, intersect equals max, subtract equals min with one distance inverted. Full operations for SDF for reference. Thank you very much. Yeah, it's been a while since I've played with a signed distance field, so yeah. Okay. Yeah, I don't know where to go from here. I could try making my own fractal, but that, hasn't gone too well in the past. I could try... Here, let me use a Voronoi. Voronoi texture. I'll use this for a height map, generator. So, I'll have this offset the Z position. So I just add this to there. And I'm going to turn off the points rendering. So let's just put that right there, put this here, shading is set to smooth, all good. Oh, dang it. What has gone wrong? Is it too small? Ah, there we go. So here's a Voronoi texture. Let's set the detail to 4. Too much detail. Glitching occurs. Yikes. Yeah, I still don't know why that bug's happening. Or it inverts like that. Well, I'm just going to assume that it's a problem on my end. Like, that should not be happening. Is the error distance too low? Let me turn that up. Let's make that even less. Nope. Glitches still occur. Not entirely sure about that. But it's like guaranteed to be a problem on my side. All that. Let's set this to be just the color offsetting the distance, the height of that. So there we can see that. Oh, Raymarching really dislikes... No, wait, no, that shouldn't be the case either. Does it just hate really sharp... Oh, I get it, I get it. It's because the distance field isn't accurate for that? I'm not sure. Yeah, here, let me just get the length from that. The length from there. Then I'll subtract using that. So here, this should make... I don't know why it keeps doing the glitching. I don't know. Let's see. What is Raymarching? So, to put it simply, it's what I'm doing right here, where there is a bunch of rays that are shot out from the camera, and the rays keep moving forward until they get close enough to a distance function. So in here I have a fractal, that is a distance function, and then, yeah, that's how it does it. My brain is starting to slow down, I think because I've been staring at this for so long. But, yeah, Raymarching, all that fun stuff. Wonder what happens if I store... No, that position should be fine. We just have that and that and that. We absolute that one in order to get the distance to that. Here, let me play around more with the, this. Okay, so now we have an entirely different pattern. Let me go into the shader editor. Why no color? Oh, I know why no color. That material node. I deleted that. So now we can have that back. Again, lighting works as intended. But this needs more detail. There we go. That's really cool. And again, this could just be turned into a mesh very easily, which that's the real power of this. I can just turn this into a regular old mesh, decimate it, turn it into a texture. That's interesting. Am I inside the fractal again? Let's set that to 1.1, play it again. Now we have that. 0.9, this is going to wreck everything, I assume. Oh, no, it didn't. Wow. 3 or 4? What happens then? Okay, nothing. Ah, it turns into Swiss cheese. And highly unstable Swiss cheese from the looks of it. 2.2. Run it again. Oh. Do I turn on the sphere renderer again? Yeah, but let's keep the resolution somewhat manageable. Uh-oh. Oh wait, no, sphere needs to go there. So instead of a grid, I'm going to be tracing from the sphere. That needs to go there, and that needs to go there. So now, if I set this to 1... There we go. So now, if we do that, that's our clipping distance. Okay, so we still are inside the fractal, which is less than ideal. But we can see the negative input of the fractal there, which is cool. Yeah. I need to brush up on my fractal things. Huh. Because I could... Should I try making my own fractal? Could be dangerous territory, but it could be fun. Yeah, let's do it. Let's copy the repeat zone over to here. So if we use a fraction node, fraction, put this into here, and then, okay, so fraction, then we're going to scale this by 0.5. And then we get the distance, and then multiply. I'm not sure what this is going to do, but I think it could be cool, so I'm going to do it. So this will be minimum. We're just going to put that into there. So if we put that into the SDF, what happens? Nothing good. So fraction... Oh no, let's get the distance by 0.5, 0.5, 0.5. And then subtract that. Here, and let me... Grid renderer. Subtract by 0.5. Let's set this to 0.1. What happens then? Nothing. Absolutely nothing. Okay. Let's set this to be 1. Okay. If you can't tell, I have not done fractals in a wait. Okay, now we have spheres appearing. And now I just need to make more spheres that blend into each other, right? So here we have 2 spheres, but they are being minimummed. Wait, what was the, okay. Min union equals min. So if I use a smooth minimum, this should blend between the two by a distance of 0.1. It's leading to the errors. And I need to remember why the errors are occurring. Oh, it's not referencing the... I'm a genius. I'll tell you. Yeah, I'm just getting a bit tired. My apologies, everyone. Yeah, there we go. Let's make them a bit bigger. I still don't know why that's happening. Fraction... Yeah, no, that should be... If 2 are making it freak out, then adding more wouldn't help. That just completely ruins it. Or is it just not a valid distance field? Add. Let's try that one. Nope. Subtract. Nope. What if I were to multiply this by -1 every single time? And let's also set the distance to the initial distance to 0. That might have been an issue. Uh-huh, yep, makes complete sense to me. Minimum. Yeah, I think I'm running out of energy for this, but anyway. Let's make some cubes, because spheres, you know, spheres are okay, but cubes are better. Or actually, let me use a wrap node. And maybe a cross product eventually. Wrap. There we go. Okay. Build our own fractals. Use the distance from 0. So that's just the regular thing. I can have multiple layers, but the multiple layers don't really want to... Oh, wait, I need to scale by 2. Oh, that's partly what was wrong. There we go. Still not sure why that's happening, but oh well. Maximum... Nope. It's okay. Let's get cubes. So, actually, let's just take out the repeat zone for this. We don't need that. I'll research fractals again another time. But we have over 50 people here still. So thank you very much for watching. Even though the momentum is very much gone at this point. So let's just get a square, which I'm not sure if those are supposed to be mins or maxes. Subtract, but we'll see in a quick second. 0.1, plug this into the SDF. Okay, yep, those I think are supposed to be maximums. We're trying to get the distance of a square. There we go, yep, that's working. So let me set this to be a bigger sphere, or a bigger square. And we can also smoothen this square by using a smooth maximum. So if I do this, we can see that now we have almost a cylinder. But let's tone that down by a bit. So we just have a very nice rounded square. There we go. Very nice and beveled. How do I make a... I'll figure that out later. A nice and rounded square. Topology is not the best, but that's just because we're doing the renderer. So if I were to use the repeat zone, I would want this to, like, have more cubes. Actually, here, let's make it so that -1000. There we go. So we just have the grid like this, so that we don't have to worry about everything else going haywire. If I were to try, once again, to use the repeat zone and all of that. Okay, let's try it once again, just for kicks. So we have all this. Here, nope, we want that into there. And then we want to minimum to join these together. And then let's feed that into the SDF. right, and we need to change this, so let me scale this by 2, which means that they'll be half as large the next time around. Yep. Set to 1.2. Ah, there we go. That's cool. We can see more and more of the cubes appearing as the quote-unquote fractal is going around. But I could also add, subtract 0.5. Anyway, you slice it. Let's change it to be that many. Okay, we don't want it to go up, so let's just do that. There we go. We're having tons of cubes in the same scene. No, and we want that to be like that. There we have it. Okay, now we're getting a cube fractal. Not the best you've ever seen, but it's decent enough. Oh, and no, I do want that there. So let's make this negative 0.4. But I still don't know why that glitching is occurring. Maybe it's because of the straight ups and downs, but no, that shouldn't be the case. Oh, maybe it's because the distance? No, the distance should be... Maybe the distance should be divided by the current iteration. Yeah, okay, so let me track the iteration. So let me try this. And then I just divide it by the current iteration. So we'll start off at 1 so that it divides by 1. Maybe it's just because the distance is getting... There we go. Okay. It's still not amazing, but it should be good enough. Yeah. Okay, to make this perfect, I think I need to set this to the power of 2. Because it's doubling... Yeah, okay. Because I'm multiplying the, there we go. That's what I was going for. Amazing. Since I was multiplying the UV map, the distance field was being multiplied as well, which we technically don't want. We just want the, yeah, okay. That makes sense. So the scale of these two need to kind of counteract each other, if that makes sense. Okay, now what I'm going to do is try to compact this by a little bit, so thank you once again for your patience. While I go and do that, so this is our cube shape. So this is our rounded cube. So, rounded cube. And then that's the cube's thickness. We divide that, or, that's our iteration counter, but do we... Okay, this will be iteration... Yeah. Yeah, that'll be fine. So I need to divide it by the iteration count to the power of 2 to compensate for scale. Scale, compensate. Because we're scaling this, we need to make the SDF do the opposite of it, essentially. So if I plug this into here and there, or the power of 2 into there and there, they should be... Yeah, they're... Okay, they're not the same, but they're fairly close. Yeah, now that's the same, is it? But yeah, the scale, since the scale doubles every single time, we need to make it so that the sign distance field gets divided by 2 every single iteration, so that, it, you know, it just works. So let's go and up the amount of these that we have available. Let's take a look. We should see so many more cubes. Oh, that looks cool. And it looks so weird because it gets blurrier in the background. But there we go. We can now just set some nice lighting. And also subsurface scattering if we so choose. So this top part is our UV map. So our position edit. And then here, let me put the... in the group. Let's put the iteration above that. I could make that an integer just to differentiate it. Yeah, let's do that. Iteration needs to start at 1. So yeah, if we had a loop ID, that would be very nice, but the Blender devs did not include it because they thought people would confuse it for each loop. And for each loops do not exist at this current time. So that's another very fun thing. Let's see, this will be join shape. And that is a very funny way of spelling join. But also this could be a smooth minimum. So let's just pull out all the stops when it comes to using Raymarched stuff to our advantage. So now we can have it all be blended. Oh, I can make... Oh, that's cool. I like that. Yeah, let's just blend it a little bit less. Now it looks like chocolate, like a blended chocolate. But that's cool. Like, see, that's the power of sign distance fields. It's like, oh, blending stuff? Perfectly fine. So easy. There we go. I could turn down the iteration count just because we're kind of going a little overboard with all of it. There we go. There we go. And I can store the iteration count. No, we don't need that. Yeah. Though it is so weird when you go off axis, because technically all these are in the right position. Just anything that's outside the camera view gets stretched. Like that. Alright. Anything else that you guys want to see about this? What if I were to vector rotate it by 45? Vector rotate vector. There we go, I got it first try. Well, the first time it took me like 5 tries in order to get the right vector rotate. So now if we do this, we can see that we have another interesting pattern. I should just try doing this in the shader editor, like make my own Raymarch node, but I will do that off stream. The one downside is we don't get all the fancy lighting and stuff like that with, Wait, if we get pixel depth offset, we may be able to Oh, wait! In Eevee Next, we might be able to in the future. I'll have to check about that. Okay, okay, so yes, interesting stuff. I'll make it so that the cubes are rotated every single iteration, which could be cool. So let's multiply this by maybe like 2. Oh wait, what's pi divided by 2? Yeah, that'll make it so that it rotates by 90 degrees, which means nothing happens. So let's do that to make it 45, I hope. Yes, that rotates it by 45 every single time. Let me turn off the smoothing on the cubes, or on the, you know, the sharp part. Like, that's what I like. Like, there's no super sharp edges. We still get a little bit of bevel even there. I like that. Let me change the color into something, you know, maybe a little bit more interesting, potentially. I don't know. Subsurface scattering, we can turn that on. Because we have all the... Let's set the weight to 1, and then we need a... Okay, yeah, changing the radius. There we go. Ooh, that's cool. I wonder if subsurface scattering works with, Raymarching. Like, regular Raymarching, not this hack to get into, Blender. Also, I'm just going to try this one. Interesting. I think I like it being sharper better. And then the blending between all of them is cool. Okay, let's let it keep running. I almost feel like the Raymarching is being half as fast as it should be. Like, I have the feeling that this needs to be multiplied by... This probably... Yeah, that resolved faster. Why did that resolve faster? Or no, wait, yeah, I know why. If I multiply by more and more, yeah, and then the inaccuracies start happening. Yeah, so that's why we don't keep multiplying by that much. The inaccuracies build up. Okay. Looks like a candy motherboard, yep. The position of the output of the repeat zone is not connected to anything? Yes. That's because the repeat zone makes it so that the position output gets fed into the input again and again and again for every single one. And so on. Oh, another thing that I forgot about. That needs to be at the end, so we start at one iteration and then it keeps going up and up and up. I forgot about that. There we go. So I'll just collapse that into there, put that into a frame. Now, named attributes would make this a lot cleaner, but since we're, you know, not connecting it to the geometry until the end, that's why that's not happening. Okay, anything else? Let's do that. Let's check if that severely altered anything. Nope, it's working as intended. Or is it? It looks like that made the blending... Oh, yeah, okay, now we got the blending back. Or is it right? Yeah, no, we don't want that. Is that an accurate distance scale? Because... Let's see. Iteration 1. Oh, no, that... Technically, it does have to start out on 2. Or does it? Because... Yeah, it kind of does, but... It's better to have that there, so I'll just have it start off at 2 for the distance calculation to be correct. Yeah, we can see that the blending distance is now even across everything again. Interesting. I'll look into that. I should label this correctly, so this is the SDF. And over here as well. No, that's actually not the SDF. That's not even the iteration count, that's just something different. Okay. So, again... Oh, yes, I can switch this out with a sphere, so let me just get the length. There we go. So here, if we do this, we'll see that it transforms, woo, into spheres instead of cubes. That looks rather cool, if I do say so myself. Then if I wanted to add in a floor, that's very easy to do. Actually, I'm going to increase this by a bit. That's interesting. It looks like a very odd pillow. Let's bring that down by a bit. There we go. Like, that's a very interesting shape. And also, because I haven't shown this off enough, if we want to get this, the projection correct, like, if we want to make this into an actual texture, boom. Now you can just Control A, and then boom, you have the texture. Because it will always project from the camera, because that's how we set it up. Once again, this technique was first made by Sean Traley, which I put their YouTube link in the chat, but I'll put it in once more. Raymarch fractals. Yeah, let's do that. Just because I want to put it in once more before I end the stream, because I'll be doing that very soon. I'll keep the monkey in here, but that should be fine. Let me label the geonode setup. So this is Raymarch. This will be geometry nodes, Raymarch. Yeah, let me add that in. GN, Raymarch, for geometry nodes, Raymarch. There we go. I like that design. That's pretty cool. Could I use smooth minimum? Let's see what happens then. This is not going to work well because essentially, yeah. Smooth minimum, or no, I'll use a smooth max on this one. So this should make, yeah, it's kind of making a diamond pattern, but not quite the way I was hoping for. Let's do smooth minimum. So let's set this to 0.1. Oh dang. Smooth maximum, just so that we can see the tops of it. Oh, that's actually not bad. We're getting a kind of floor pattern as actual geometry. Huh. Cool. Cool, cool. Let's set it to 1. Or no, wait, we don't want it to be exactly 1 because, yeah. Just get a ton of x's. Interesting. Pi divided by 2. I should have set it to 0. But here we can see, there we go, the kind of inverse of that effect. I could make it blend. Looks like the top of a pie. Interesting, yeah. And here we just have like a weird fractal there. Then if I let it play for longer, it's kind of disappointing. So let's go divide by 2 once more. Smooth minimum. No, smooth max for both. I keep forgetting. Smooth max, do. And there we have it. Yeah, we're almost at 2 hours. Oh, dang. Oh, I know why that's happening. I forgot to set the subtract back. So, if I wanted to fix the blending problem with the floor, where it doesn't look right, that's because this gets smaller and smaller until it becomes so small that the rays just go straight through. So I could just go and put in a floor SDF and then it should be okay. But yeah. Actually, let's set this to 2 and -2. What happens then when I change the wrapping? Okay, yeah, we just see that happens even more. Okay, I think I'll call it here. Thank you all for watching this fractal experiment. This was very cool. Again, special thanks to Sean Trelly. Again, I apologize if I'm pronouncing the name wrong, for making a tutorial for this technique. Go subscribe to them if you haven't already. Yep, and I'll just, for the endpoint here, I'm just going to show the... Oh, so that's what they're doing here. They're dividing the distance so that the fractal distance is okay. Kind of like how I was doing. Let's set this to 1.333 so that we can see the actual fractal once again. So once again, thank you for watching, and I will see you next time. Have a good one.